to stop that. Why have I spotlit you? I'll spotlight me. Haha. Let me see. All right, so as people log in, let me know if you have questions from any homework stuff. And then I want to add you some. I want to add you something. I want to show you something I added. Man, I didn't get enough sleep last night. This is going to be exciting. All right. So, does anyone have questions from homework? I just had a couple questions earlier. Anybody else have questions?
I have a question.
Yes.
Yeah, it was for 1.3. It was like for like number 8, and it was like 6, but they had a similarity. I had like a trouble understanding like from square units to like square inches.
Yes. So this is a really cool concept that this section kind of builds up to. If I'm talking about just distance, it could be feet. You know, let's talk about inches. Let's talk about inches, because then I can actually show you it's roughly that, right? So if I'm talking about just length of something, I can lay an inch next to an inch next to an inch, and that's why the units are just inches. If I'm talking about area, here's a very weird question for you. What is area of something? What does it really mean?
The whole thing.
Yes.
Ish.
Say again.
The entire area.
Whole volume.
So to me, the word that comes to mind with area is cover. How much will it take to cover a shape, right? Perimeter is how much will it take to go around a shape. Area is how much will it take to cover a shape. And then what's volume?
How much it takes to fill up a shape?
Beautiful. Look at that shit. That's awesome. And when you start to realize, so just to go around a shape, I go in one dimension, to be honest. I just put an inch next to an inch next to an inch, and I add them up and I get a bunch of inches. But to cover an area, I can cover it with little square inches, inch by inch, right? Step by step. No. You guys semi with me? So that's why area is in square units, because how do I cover an area with little squares, little tiny squares to cover it? And then of course, when I go to volume, don't I add a height in also? So then I'll have a length and a width and a height. That's 3 dimensions. That's why volume is cubic. Does that make any sense at all? I mean, it's okay if it doesn't. Just let me know.
Could I ask a question?
Let me finish about this
okay.
one. I'm sorry, Carrie. You can come in a second, but I just want to make sure everybody's got. Is that who asked that question originally? Does that help?
No, it was me. It was Ryan.
Does that help?
In a way.
I pretty much gave number 8
Yeah.
away. So I mean that by definition I have overhelped.
Yeah.
I love the image you get in number 7. It is all about filling up a space. And how do you fill up a space with little cubes? How do you cover a space? Little squares. And how do you just move along just a single, inch, not squares? If you have squares, then you're not moving in just a line. You're covering, and that's area. Is that okay? Or are you guys like, dude, why?
I'm still confused.
All right, so, do you agree? Let me see. I mean, let me see. Does that idea, that one word kind of definition, or at least sense for what area is when I say cover? So to me, the word cover is what area is. What does it take to cover a shape?
So would you do like length times width times height?
So for mathematically, it makes complete sense. Perimeter is just adding up sides, right? Side 1 plus side 2. So it'll be inch plus inch. So you're going to get some like inches. Area is going to be length times width. So I'm going to get so many inches times so many inches. And what is inch times inch? Inches squared. I mean, so mathematically, it makes a ton of sense too. And of course, like you just said, volume is going to be length times width times height. And that'll be inch times so many inches times so many inches. So that'll be cubic inches. That'll be little cubes. But then visually, it makes so much sense. So if I want to go around this shape, I'm just going to add up the side lengths, and that'll be just inches. If I'm going to cover this shape, I'm going to cover it with little, let me see if I can make this make any sense here. That'd be nice, Jeff, considering it's your job. All right, there we go. Let me just do this, get this over with. There we go. I'm going to cover it with little cubes. So if this is 4 inches long and this is 5 inches long, right? 1, 2, 3, 4, 5, then 20 little square inches. What did I just say cube? I'm sorry. 20 little square inches. Like here's 1 square inch. Here's another square inch. That's 2, so forth. There's 3 square inches. So how many total square inches cover this thing? 20, and that's 4 times 5. But how many what's cover it? Square inches cover it. And then of course, I can get into filling a space. Just put a bunch of little cubes next to each other. And then I can count each cubic inch. This is inch, inch, inch. That is a cubic inch. So if I want to fill up my room, I can fill it up with little tiny cubic inches. So I'll count how many little cubes it takes to fill up the room, and there'll be that many cubic inches. So volume is in cubic units, area is in square units, and some kind of length is just in to the first power, it's just straight units. Is that better? Now, to me, this is what makes the most sense. Just mathematically, it's like, well, there it is in your face, but then it goes right into a visual also. I'm getting
okay.
Yes.
I have a question. So if you're going to use that and to kind of put into perspective on question 7, I know it's saying like add up for the total amount, but if we were just trying to find the area, we would just do 6 times 3 to get the area, which would be 18. And then, is that correct?
If you just wanted the area of the base of that,
Okay.
it would be 6 times 2, right? There's 2 this way. Are you with me?
Okay, that I was going the front side, so that's not how you do it. I'm looking at the front side.
Well, oh, I see. I'm sorry. I was looking at the base. You're looking at the side. Okay, I'm with you. I'm with you. See how the base is only 2 in the depth?
2.
Just to make sure you understand where I got 2 from. So you're looking at it face on. I'm with you. So that the area of that face that's looking at us would be 6 times 3. I'm with you.
Okay.
Now watch. How many of those faces are there as they go in? Aren't there 2 of them?
Yes.
That's why 6 times 3 times 2. You add, you don't add them. You multiply in that next dimension.
Okay. And that would give you the total area of the cube. That would give you the total area of the cube if you did 6 times 3 times 2.
That'll give you the total area of that shape.
Okay, that's
All those cubes. So you can either just count the cubes, and then they're telling you the multiplication will get you the same answer, right? Because we already know from the previous section that multiplication is just repeated addition, or maybe it's this section. Is that all right? See how this stuff does come together. It has to agree with itself, or else we throw all of it out. Let me see. Is that all right for that one? Any other questions on that idea? 6, 7, 8. All right.
No, I understand it. Thank you.
Oh, sure. Who did I skip over? It was started with a C. I can't remember.
It was me, but my question was answered. Thank you.
Oh, sweet. I love it. That's the wait and see approach to teaching. All right. Okay. Let's see. Anything else, guys, before we march on like the crazy peoples we are? Here, I want to show you something. Oh,
Yeah, before you go.
Who is this? Oh, it's Linnell. Let me change.
I was having problems logging in. I was just scrolling there for a minute. It's one of the older ones that I keep puzzling me. Remember that the -3 to the +3 and the -15. Remember that?
What, 3 times -15?
Let me see what question it was on.
Was it from the review section or from the?
No, it's on 1-2.
1-2, okay.
Yeah, and it was the question where it had the -15 question like 3.
Question.
One of the income earnings.
Oh, that's right. So again, anytime you want to know the difference between 2 time periods in this case, right? 2008.
Right.
You take where you ended up,
Right.
minus where you started. I mean, that's how we do it, isn't it? I mean, if you look at 2010 to 2011, you don't even realize you're doing this, but how much did it change by?
2010 and 11 changed by 13.
13, right? And you don't even necessarily realize that you're doing 20 minus 7. So how do I do
Right.
2008 to 2009? You do 3 minus -15.
So would that be minus -12?
No, careful. What is minus a negative?
Oh, 3 minus.
3
oh,
minus.
no.
Let me write it down.
Yeah, write it down. That one I don't know. I've seen it several times, but it's not sticking. This
3 minus -15. What does minus and negative do? These two negatives?
cancel out each other, so it's just 18. Huh?
There you go. And like we talked about, I mean, I do want to see the math, but you can see how the math matches reality because, get in there, here it is. I've got to go up 15 just to get out of this hole. And then I
Right.
went up 3 more. So, I mean, just looking at, I know it's going to be 18, but I want you to realize what the math looks like. And the math agrees it's got to, because math is a way to describe reality. So whatever the shit reality is, math is that too, right? All right. Is that all right?
Yeah, thanks.
Sure. This is what I do.
Okay, again, page 46, number 5, C and D, I was having trouble with.
All right, let me see. Page 46.
Yes, number 5, C and D.
Oh, yeah. Okay. Let me see. So this is good. All right, so some of you guys might not have gotten here yet, so this will be a nice preview. But distributive property. All right. Do you guys remember distributive property? Sometimes math people make names that actually make sense. We don't always do that, I will admit. But distributive property makes all the sense in the world. So I want you to realize something. Like if I had a problem like this, why can't I follow order operations straight up? Because what would order operations say to do first?
Add X and 4, but you can't because X is a variable.
Yeah, I don't know what the hell X plus 4 is it? Is it orange? I don't know, right? So we have to figure out another way. Now, somebody help me out. I'm building up to your question, by the way. What does this by itself mean? Don't say 3 times X. What is multiplication based on?
3 or X plus X plus X.
Yeah, repeated addition, right?
Right.
So what's 3M? M plus M plus M, Jeff. Well, what's 3 of these? This plus this plus this. Thank God I didn't say 8. All right. You guys with me? Math don't care what is there, the particular pieces of a problem. It cares about the operations. So it says 3 times anything is write that thing 3 times with pluses in the middle. Okay, 3 times this is write that thing 3 times with pluses in the middle. But then what can I do if I write it like this? Now what can I do?
To the third power?
No, it's not times. It's plus.
Oh, yeah.
X plus X plus, because I can add this any order I want to. So what's X plus X plus X?
3x.
And what's 4 plus 4 plus 4?
12.
Of course, please, dear God, I always get at least one student that's like, why is he doing all this? Why doesn't he just distribute? Well, I'm proving distribution works. 3 times X, 3 times 4. This is why distributive property works. So on some level, if I didn't explain this to you, you should be like, Jeff, wait a minute. Why are we breaking order operations? You said it was so important, and all of a sudden, I shouldn't be able to do shit with this, and you're doing shit with it. Well, this is why, because I rewrite it so the order operations follows. It allows me to do more. If I rewrite it, I can do more. I can now add whatever order I want. You guys with me? And does that help with that
I'm
question?
with you, but I'm gonna need some more help on that one.
Yes.
So for example, so let me show you a straight up problem without all the explanation. So if I had this, A times B minus 7, distribute. So it would be
AB.
A times B, so AB minus
Minus
B.
7.
7A.
7A. Do you see the B and the 7? Yes, and what they both get, didn't they both get an A? Because you distributed an A to both.
Oh, okay.
That's all distribution is. Now you understand why distributive property works, because now this is a little bit weird. Let me see if you guys can really go along with me. How many B minus 7s are there up here? There are A of them. How many B's total? There's ABs. And how many 7s? There's A7. So it gets a little bit weirder when this is not a number, but the idea doesn't give a shit if it's not a number. The shortcut still works. So one more. So what if I had, what do you got, Jeff? W times W plus 5.
W.
W squared.
W squared, I like it.
And that plus W5.
And then of course we always write the number first, right?
Okay.
Just because to make it a coefficient, it makes it easier.
Oh, okay.
Yeah, you give that guy a belly. Shabba! Become a belly. Yow!
Plus 5W, okay.
So they each got a W. He had a W, he got another one. Now he's got 2. That's a 5, he gets a W, now he's got 5W. You get a W, you get a W. It's the Oprah Winfrey property. Everybody gets a W. Is that all right? You guys with me? Okay.
So if it's just the numbers, we just distribute it to the like do exactly the same way. Don't do the inside the parentheses first.
Because I can't. But I want to show you, if I had this problem, do you want to distribute? You could, it would still work, but what am I allowed, thank God, to do first?
Parentheses.
Yes.
Yeah, now I got lost. See, I could do this. It would work. I could do this. It would work. But my God, why would I? 48 minus 46 becomes beautiful, and then I just multiply. So I do order operations when I can, because normally that makes it easier. If I cannot, there are ways around it by reorganizing the problem.
So what you just did, can you hear me?
Yes.
Got it.
You reorganized it to 11 and then subtracted that 2, then you multiply. And that's it.
See, if I can do order operations, I normally do. If
Right.
I can't, there are little weird ways, and in fact, distributive property is the first kind of way around it that we learn. I can't do order, I can't do B minus 7. So thankfully I can still do something. I can distribute the A and get somewhere. Just in case you guys don't believe me, anybody have a calculator handy? What is 11 times 48? What would that be? 528. All right. If you're gonna help me, nobody's gonna help me. All right.
Oh, 5 times.
528. Okay. And then 11 times 46.
506.
And what's 528 minus 506?
22.
Same answer, right? Nothing magic. Nothing magic. It's just math. Math don't care which way. But this was a lot easier, right? Hell yes. Okay. I like it. All right. So that's all right, Ryan. You got to do what you can. I want to show you something I added. I figured out my office hours, my, what do you call it? Extra office hours. Let me get it up here so I can show you. And I made a module out of it. So I'm just going to keep it up at the top. And these links for the office hours are going to work the whole semester. So do you see up here where it says extra office hours link? So if you click on this, starting September 1st, so not today, I'm sorry. Today I've got a meeting. It's like a one-shot meeting. And then the rest of the Tuesdays, I'm going to keep it free. You guys with me? And then, so starting this Thursday, it'll be 2 to 3. So this link here will take you to every Thursday office hour. And this link here will take you to every Tuesday office hour. Now, just to remind you guys, I'm going to have all my students from all my classes can come to these. So if I get a bunch of few people, I might make breakout rooms for 96, for 160, for 176. Just so you know what to expect. Everybody with me on that? So you can come, you don't have to come. No teacher, let me remind you this, no teacher can make you attend times outside of the scheduled times in the schedule. Everybody hear me? So if there is a teacher making you do that, especially if it conflicts with another one of your classes, no, you tell somebody, you reach out, you find out who their chair is and you reach out to them, or you reach out to admissions and they'll get them in trouble. I mean, there's been some incidents of that. And anyway, so it's annoying. Especially when it conflicts with my class. You don't mess with my class. All right. My computer calculator, we were talking about 1, 3. I don't understand what that means. Tatiana, what's the question? Yes, we are talking about 1, 3. Was it section 1, 3? Is that what you mean? I forgot where we were. I think it's section 1, 4 is the question, right? It was page 46.
1, 4, yes.
Yeah, I mean it's the
46.
It's the like 1, 4 prep thing. Yeah. So it was page 46. Is that the question, Tatiana? So I haven't done 5C yet, but now you should be able to do 5C. That was the original question, I think. Now you should be able to do it. Okay, let me know if that's not a true statement. Anything else, guys, before we get back into things?
14x. 2.
I'm gonna mute everybody real quick.
Could we do one with the letter and a number in the parenthesis? Like for D, for 5D on the same page.
So is the problem like, okay, so up here I've got a letter and a number in it, right?
So say if it says A times 7B minus 7.
So you're worried because it's got a little extra shit attached to everything, right? So watch this. Here's a really nice way to do these kind of problems. So let me give you something even grosser than what's in there. Look at that. That's yummy. All right, sorry. It's always a little creepy when I do. It's so yummy. So I still want to distribute. Watch what you can do for yourself. Watch what you can do for yourself. you can just write the problem you eventually have to figure out. Do you see what I just did? The property is this times this. Let me just write that. And then it's this times this.
Oh, we're just gonna be.
I don't know. What was that? Everybody all right?
It's negative 7b squared, isn't it?
Oh, thank you, thank you. And now you can just focus. So I applied the distributive property, but I didn't actually try to do everything in my head. Now I can focus on this. So what would I get here? I get -4. How many A's?
3.
3. And how many B's?
2.
You guys all with me? So that is if you got so much shit happening everywhere, you don't have to do it all in one step. You can do this times this, and then this times this. And now you have 2 problems you can focus on. -4 times -7.
28.
Positive, I love it. And then 2 A's, no more A's, and then
3 b's.
3 B's. Done. So that one is actually worse than the problem they give you, but that is a method you can use so you don't have too much in your head. You can write down for yourself what you got to do, and then you can do it.
Got it. Thank you.
So that is a mistake that teachers make, me included, is you make it seem as if you're supposed to do it in one step, and you don't have to. That is one way to write kind of an intermediate step for yourself. Let me see. Okay, anything else, guys? I did not prepare well. I need more liquid. Okay. With no more questions, we are going to look at 1.4. We're going to start looking at it.
Really fast.
Yeah, we do. Let me see. Okay. Everybody mute themselves. Whenever I share screen, I never remember how to mute everybody. There, I know. There we go. Got to learn that shit. That's important. All right. You gotta love it when they have a quote from Albert Einstein, but it's about freaking compound interest. So let me ask you this. Have any of you guys ever heard this? Would you rather that I give you $100,000 right now, or I give you a penny today and then twice as many pennies tomorrow and then twice as many pennies the next day for a month? Would you rather get $500,000 just right now, $500,000 done, or a
Isn't it the pennies?
Say again?
Isn't it the pennies?
You know why? I mean, you can sort of guess that it must be the pennies because it sounds like it's wrong, but that's the point of the little trick question, right?
I don't know. I think I remember some Indian story about like a lord or like a king promising some peasant like 1 grain of rice, and then the next day 2, and the next day 4, and so I imagine it would get pretty out of hand.
There are a ton of similar things: money, rice, livestock, whatever. All with the same idea. So let's look at this on the board before we go into the book. My God, Jeff. All right. So if I give you a penny today, so today, first day, you get 1 penny. And then the second day, I'm going to give you twice as many as I gave you the previous day. So I'm going to get 2 cents. How much am I going to get on the third day?
4.
4 cents. Do you see how I really want you guys? Let me see if you guys can get this. Let me do one more. Well, how many I'm going to give you on the 4th day?
8.
8 cents. Right? I mean, does everybody get the idea? So what I want to know is, okay, well, how many am I going to get on the 30th day? So wasn't this is 1. This is 1 times 2. This is 1 times 2 times 2. Are you guys seeing this? This is the most basic thing that math tries to do. It tries to find a pattern so I can make predictions about other things. I don't want to make this list down to 30. I'm like, math, come do your job. Tell me how to figure out 30. I just want to plug 30 in. What's another way to write 2 times 2?
2 squared.
So on the third day, I get 2 squared cents. And then this is 1 times 2 times 2 times 2. So on the fourth day, I get 2 cubed cents. All right, let me stop just for a minute. Just please let me know. You guys, that's what happens if I double. I keep getting 1 more 2. 1, 2, 2 twos, 3 twos on the fourth day. So on the 30th day, I'm going to have 2 to the what cents? Does anyone have the calculator? What is 2 to the 29th power? Let me do it too. Anybody get that? No? Anybody have a calculator? Do you know how to do the 2 that?
5 slot 500.
Oh, wait a minute. Let me hold on. Let me
6 million 8.
There it is. There's the button. Okay. 536870912, right? So let's see. Now what's kind of wrong with that? Oh, now oh geez, we all need glasses. Okay. What's wrong with that number sort of right now? We don't normally deal with that many freaking cents, right? So what am I going to do to that number to make it dollars?
You have 100.
Yeah, so I've got, all right, Jeff. 536870912. I think that's all the numbers, right? Am I only missing 4? 1, 2, 3. Yeah, do you guys see that? I'm sorry. I'm a numbers guy, so it's kind of cool that I'm only missing the number 4. If I divide this by 100, the decimal goes back twice. So I actually have 5368709.12. Put some commas in there. How much money is that?
$5 million.
Yes. So, and it's even better than that. On the 30th day, I get this much money, but didn't I get the previous day? Didn't I get something on the order, like half of this? So it's even more. So my question was, do you want $500,000 now or a penny and then double that every day? It totally sounds like the penny sucks. You're like, I don't want a penny. And then you give me 2 cents. Who gives a shit? But we don't realize, this is what that quote by Albert Einstein means. The power of, get over there, compound interest. Doubling every day ends up growing like stupid big pretty quickly. There's no way you would guess this, right? It's just not something that our human brains are wired to understand immediately. Okay, maybe. It's kind of related to, I'm sorry, Giovanna, you have a question?
Oh, well, I was going to just say, like, isn't it like penny stocks? Like, isn't that how penny stocks grow or no?
To be really honest, I don't know a lot of stuff.
Okay, just wondering.
I know about like penny slots at the casino, but.
All right, I'm done. Thank you.
You're welcome. What was I about to say? Come on, Jeff. I forgot what I was about to say. Okay. There was something I was about to say and I forgot. All right. Coming back to this. Oh, yeah, that's right. Has anyone ever heard about how many total combinations of toppings can you have on a pizza? And it's in the millions. It's our brain cannot comprehend. If I have like 13 possible toppings, I'd have to do the calculations. It's in the millions somewhere of the different types of pizzas you can create with all the different possible combinations of toppings. Our brain just can't get that easily. And that's why probability is difficult for our brain, because probability is based on that to some degree, some parts of probability. Okay. Let me come back to this. Where'd you go? All right, why are you all over the place? There you are. All right, here's the dude with no money. That's interesting. That's basically me in college. I love it. Actually, I was worse in college. I lived a very plastic life. Does anyone understand what I mean by that? in grad school, man, that credit card was like magic. And then the bill came. I'm like, magic is gone. All right, let me see. Blah, 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 blah. Okay, so what I want to get into is we're going to talk about interest today. There's something called simple interest and compound interest. Does anyone know, without reading that, the difference between those two? Anybody ever heard about compound interest and what that means? So what happens in a bank when you put money into an account and you just let it sit? It accumulates money, right? There's an interest rate on it. We're assuming it's like a savings account or like a checking account where you have a ton of money in there and it makes interest. They calculate that interest not off of just your original money, but off of, they calculate it, they add money in, and then they calculate the next amount of interest on that bigger amount of money. That's called compound interest. It compounds on itself. Simple interest is just, if you put $1,000 in, they'll just calculate how much 5% is and just keep adding that same amount every year. So for example, here's an example of that. Whoa, shit. I love this book. It just jumps all over. So let's look at account 1. I put $1,000 that pays 5% simple interest on that $1,000 each year. So that means it calculates it once and then just keeps adding that same amount. So can somebody help me out? How much money will I add in after the first year? How much interest will I earn after the first year?
$50.
Yes, everybody see how he got that? Does anybody see how he got that?
Yes.
What did I just do? All right. So all he did was 1,000. Okay, here we go. This is exciting. 1,000. Those almost look like zeros. Times 5%. What's 5% as a decimal?
0.05.
All right, Jeff has graduated first grade. Good job, Jeff. So that's $50. So he's going to make $50 every year. That's simple interest. Simple interest doesn't give a shit how much money you have in there as it goes. It just cares about what you were at the beginning. So at the end of the first year, he'll have 1,000 plus 50, and then you just keep adding 50. And that seems like a pretty decent deal there. But let's do it again where it's compound interest. That's account 2. You put $1,000 in, it pays 5% at the beginning of the current year of the current account balance. So, oh shit, all right, so everybody got that. What sucks when I do it like this is I cannot leave this on the screen. Okay, I'm gonna clear all that. Hopefully you got all that written down. I'm gonna clear it. Going. And now I gotta do this so I can move. All right. So for account 2, the first year, it's 1,000 times 5% again. It's still 50 after the first year, and now I've got 1,050. But now the second year, what am I going to do? I'm going to add in 5% of not 1,000. We're going to add in 5% of 1,050. So that's what compound interest does. It says, okay, you earned the $1,000, but now I'm going to give you interest not only on your money, but on the money your money makes. This is what that old adage is. Anybody heard you got to have money to make money? Which is really evil. If you stop and think about it, we can keep people out of that. And oh, too bad for you. Anyway, I don't want to get too political.
I get it.
You understand? Okay. So help me out. What would go here? What would I do to calculate what goes here? It's a 5% account, but what am I doing 5% of now?
1,050.
Yeah, so help me out. Somebody else tell me what 5% of 1,050 is.
52.5.
Was that just another one of your personalities? 52.5. I like it. So 5250. Oh, I got somebody chatting at me. Oh, thank you, Lauren. I got to keep an eye on the chat too. So now, how much do I have at the end of the second year? I've got, if I add that in, I'll have $1,102.50. Rah! Now, I want to, does anyone realize what I'm going to do after this? Because can you imagine, what if I leave it in there for 70 years? Do you want to keep making this chart and have 70 freaking rows of this chart? Or do you want to say, math, come do your job, right? Help me out. This is why we created you, math. So I don't have to make a freaking 70-row chart. Let's do one more row. So now I'm going to do 5% of what I have now. Get in there. Here, 1102. Oh, this is so excruciating. I'm so sorry, but that's just the way things are. So what is 5% of 1102.50? This is going to be a little more. Oh, there's somebody's got it for me. Lauren's got it. 55. And of course, you got your 12 cents and then a half penny. I love it. So at the end of the third year, I'm going to have $1,157. Keep your eye on me here. You never know when I start to go off the deep end. I think it's this. Bop. Right, all I do is add in that new money I made on top of how much money I already had. All right, let me stop for a minute. So up here, we had, it was at the end of the first year, we had 1,050. That's the same thing here. At the end of the second year, we had 1,100. And some of you guys would go, oh, I got a whole $2.50 more. Well, hey, man, that's nothing to sneeze at. And then at the end of the third year, I had 1,150, and now I've got $7 more here, almost 8. Is everybody with me so far? So up here, what if I wanted to know the 70th year? Let me see if you guys can figure out. So at the end of the first year, I added 150, right? Not 150, I added 50. How much did I add for the second year? I added how many 50s?
2.
It's crazy. So for the third year, I added 3 50s. For the 70th year, I'm going to take where I started plus 70 50s. That's the pattern I see. So a lot of mathematical equations capture patterns that we see. Not every math equation, but patterns is the most basic thing math is about. Do you guys, even if you can't appreciate how horrible my writing is, do you understand where that came from? I just saw the pattern. I keep adding 50. So if I want to go to the 70th year, at the end of the 70th year, I add 7 50s. I mean 70. I take that many steps. So what would that be?
3,500.
Plus the 1,000, right?
4,500.
All right, so that's pretty good. That's a pretty good amount. You just got to wait 70 years to make $3,500. Well, let's see what this one does. Okay, this one's going to take a little bit more work. I might want to do this on the board because I don't know if even I can handle looking at my crappy ass writing. Let me just give you a minute. Get what you need from this, because I think when I stop sharing, it's going to go away. Please let me know if you have a question right now. And one level of this is, do you understand what we've done? And the other level will be, what am I going to have to do by myself for homework? And we're going to look at that in a minute too. So don't freak out yet. All right, I'm going to stop sharing. Boop. Okay, so let's recapture what we did in that second account. What time is it? Okay. So in that second account, at the end of the first year, so we did 1,000 plus 5% of 1,000. All right. That's what we did. And then the second year, we did 1,050 plus 5%. Get in there. Of 1,050, right? Because now we did 5% of the new amount. That's what the compound interest does. It makes money on top of the money that you made already. And that's how we got to, and I wish I should have written these down myself, but what did that come out to be? 1,052.50? Is that what it was? No, Jeff, 1,100, what was it? So it was 1,050 plus 52.50. So it was 1102.50. Yeah, okay, that sounds right. So now watch this. This is where you guys are going to have to go with me a little bit. We're going to develop. Can you see how this one's harder? I can't see what the 70th year is going to be because this number keeps changing. So let me analyze this a little bit more, and I'm going to drive you guys a little bit crazy. The middle step of this is going to be a little bit freaky, and then we're going to get to a very nice equation that captures the whole idea. So what we actually did, what was this? This is where I should really have more than one color. Let me see if you're working red. This was this, 1,000 plus 0.05 times 1,000. Right, that's what this was. And then this is plus 0.05 times 1,000 plus 0.05 times 1,000. Okay, this is disgusting. So all I did was I replaced this with what it is plus 0.05 times, and then what was this again? That was this business. Bam. Isn't that gross? You guys, I'm sure you agree with me, that's pretty gross. All right, so here's a better way to look at this. So that's disgusting. This would actually lead to something good, but I don't want to do it this way. Let's look at this real quick. Do you remember that distributive property we just talked about earlier? If I can do that one way, I can undo it. That's the beautiful thing about math is it goes both ways. Don't judge. So for example, let me show you a quick example because this one's a little bit freaky to start with. If I have 2x plus 4, can you rewrite that as a number in front of a couple of pieces? What would have led me to 2x plus 4? What would have been outside?
2.
Yes, and then of course twice x is 2x plus twice 2 is 4. So I can do distributive property in reverse. And that's actually called the Gcf method of factoring. Does that matter? No, I just call it undistribution. Just to make up a word. I love the English language. Now, I can do that here. What do both of these pieces have in them?
1,000.
1,000. Now, what's 1,000 divided by 1,000?
1.
And of course, that divided by itself is 1, so I just have the 0.05 left. All right, now, I know I have left some of you guys behind a little bit. Let me just let you absorb and consider a question. What did we get from doing this? We got 1,050. What is 1 plus 0.05?
1.05.
And some of you guys, I considered a few different ways to teach this lesson today. And the other way would have been this. If you increase the price of something by 5%, right? That means that it is now more than 100% of what it was. Let me say that again. If I increase the price of something by 5%, it's now more than 100% of what it was. In fact, it's 105% of what it was. Isn't that exactly what this says? This is 105% written as a decimal of 1,000. Okay. I just had somebody leave. Damn. So now I can look at this. Now that I've written that first one in a better form, what does the second one do? So let me, somebody got what they want from this? I'm gonna kind of erase it and rewrite it up here. I'm gonna do it. Here we go. I'm gonna do it. I'm crazy. I lost somebody else. Damn, they're dropping like flies. People really hate this. Hold on. Let me rewrite the first year here a better way. First year, the amount in the account is 1.05 times 1,000. The second year, the amount in the account will be 1.05 squared. So let me write this a little bit better. You can do it, Jeff. You write this a little bit better. You make it look the way it's going to look for you in the book. 105% of 1,000. Now I'm going to apply this 5% twice. Now double check that for me. Can you do that in your calculator? 1,000 times 1.05 to the second power. And it should be 1102.50. Has anybody verified that yet? So if you have it should look basically the same in a scientific calculator, but let me see, let me get my focus ready. Hold on. So it should look like that, 1,000 times 1.05 squared. And we got the same answer, right? 1102.50. Because what is that? Holy shit. Sorry, hold on. Where am I? Okay. Because what did the second year do? It applied 5% to the new thing. So what I'm kind of missing here, let me make sure you guys really understand where this line comes from. I'm going to do 105% of where I am now, which is this. So what's a better way to write all this shit? Well, 1.05 times 1.05 is just 1.05 squared. Did somebody? All right, I just remembered what it was. Okay, let me let you guys write that down. Try to formulate a question if you have one, and I'm going to turn some air on and start to get hot in your minute.
I have a question.
Yes.
So maybe this is why you said to do it on a calculator that supports the I forgot what you call that, but the little two. Yeah, the second power. So how does that second power work? Because I just did it the dumb way, which was like multiply 1.05 to 2. Like one.
Can you turn on your webcam, or do you have a webcam? Who am I talking to, by the way? Let me see.
Giovanna.
Hey, Nikisha. Let me see now. Giovanna, can you turn on your webcam? Let me see. How do I?
It's on.
There you are. Okay. So let me. Why can't I do that? That's so weird. All right. All right. Can you hold up your camera? I mean your calculator to the camera.
I don't have one. That's what I'm saying. Like
sorry.
I don't. That's why is it you only use those with the calculator? You can't do like written math using the power of 2.
Oh, now what's going to suck is we're about to do 70.
Mm,
We're about to do the 70th power. You see what I mean?
Yeah. So you
Oh.
definitely do need calculators for the whatever powers.
So you definitely need a calculator for this class. It doesn't have to be a TI.
I have one. It's just not charged.
Understood. Okay. But if anybody has a question in general about how their specific calculator works, I can always just spotlight you. You can hold your calculator up for me, because most of the scientific calculators have a button that looks like this. And that's your to the button. A TI calculator has a button, oh, Jeff, that looks like a little carrot, little up arrow. That's what I call the to the button. Yeah, there you go, Giovanna. So you just got to charge that bad boy. Do you see the little up arrow underneath the clear? So if I wanted to do 7, oh shit, you can't see shit. Anyway, 7, and then I would hit to the 5th power or whatever. So that's the to the button. If you have a scientific calculator, it's like an X to the Y button or Y to the X. I don't know, it depends on the calculator how they put it. Okay, so I'm going to assume everybody's got all of this written down. So now, remember the first account, account 1. At the end of 70 years, it was it 4,500 bucks? Yes. Remember that? We did that at the end of 70 years. So for account 2, 70 years would look like this: 1,000 times 1.05 to the 70th power. Now give that a try. Let's see what that is. Jeff, you got to do, yeah, there we go. Getting old sucks, man. Okay. I still remember the first day I had to get these. It was really hard for Jeff to do, but now I'm like, screw it. I can read now, so what the hell? Does anyone have that answer? Oh, there we go. Lauren's got it. So what has happened? Why is that not? Oh, you're missing. Okay. It's not quite right, Lauren. Yes, okay. You missed a decimal place or something. That had me concerned for a minute. It's definitely, now you know it's going to be more than 4,500. What you don't realize is how much more. I get $30,426.43 rounding. That's a difference of like $25,000. Do you follow me? And of course, this same math we're doing can be positive, like making money in account, but it could also be negative, like paying back student loans and the way that the interest works on student loans, or paying off car payments. You end up paying so much more than the car actually cost in the first place. I have no idea if anybody's realized that yet. So what is the general formula that we have now? Let me write down what the general formula is for any kind of account that's a compound interest. It's this. Has everybody got this? Is that impressive difference? I mean, they both waited 70 years, and this guy made $25,000 more money, or more than that. Okay. What time is it? Okay. So if I have, let's see if you guys are cool with this. If I have an account, compound interest account, with the interest rate, Jeff, how do you spell interest, dude? We'll call it R. Is that all right? Let me call it capital R so that it doesn't get lost. Oh, you guys are going to love that shit. Right, the rate can be anything. It doesn't have to be 5%. It could be 4.7%, be 8%. Right, so we used 5 before, right? And with the principal, oh, Jeff, is it PLE, I think? We'll call that P, amazingly enough. Then the amount of money after T years All right, let me stop for a minute because I am throwing a lot of variables in your face. But every part of that problem that didn't have to be the amount, did it have to be $1,000? No, it could have been however much money. So we're going to call it P. Did it have to be 70 years? No, we're going to call it T years. Did it have to be 5%? No. So I want an equation that will work for any values of those. So it'll be, what did we do? We did it, recall, we did 1,000 times 1 plus 0.05 to the 70th, right? So in general, it's going to be the principal, the amount of money we put in, times 1 plus R, where R is a decimal. Is that right? Let me make a capital R, Jeff. There you go. To the T. Holy shit nuggets. Stay with me, please. I want you to really, do you understand how those are the same thing? If P was 1,000, R was 0.05, and T was 70 years, they're the same. But what if I said, well, what if I put in $3,000? Okay, put a 3,000 there. What if it was a 7% account? Okay, put 0.07 there. What if it was 60 years? Okay, put a 60 there, right? That's what formulas do. They capture the idea independent of the specific values in a situation. There's the idea. There's a specific situation. There's the idea it used. So let me give you a problem to try, and then we'll call it a day. So what if you put $3,000? Oh, sorry. Everybody's all right. $3,000. Let's say the rate is 3.5%, just to make it interesting. Is everybody, you with me? And let's say, what would I have after 20 years? Try to figure that out. So T is 20. Try to put that together and figure that out. And again, the brain doesn't really latch on to this easily. So it's really difficult to estimate what it's going to be. Don't say anything when you get it. Just hold on to it. Oh shit, where did I miss? Oh, okay. There we go. I like it. Oh yeah, okay. We still got to do that too. All right, anybody have the answer? All right, I got one possibility. Anybody else get that same thing or something different? Anybody else do the problem? Same? Yeah, that's what I got. It's almost $6,000. So it almost did what? Started with 3,000. It almost
Double.
Almost doubled. So if you have any interest in like accounts and business and all that kind of shit, you got this idea of doubling time. That also deals, this same kind of work, the same kind of math deals with bacteria reproducing and becoming more and more and more and stuff like that. So it's, I figured we should probably do a virus problem or something because we're living in a virus problem. So let's not talk about it. So money's better. Okay. We actually have, there's an idea in section 1.4 that we still need to cover. but I think I'm going to call it for today, and we'll finish up one for it's linear growth versus exponential growth. Does anyone ever watch horror movies or like even viral outbreak movies back before we were living in one? And they say something like, has anyone ever seen a movie where they said, it's growing exponentially? So I always think about like the Blob. Today it's here, tomorrow it's there, and the next day it's the world. So exponential growth, which is what this is, because it has an exponent. It's exponential growth. Grows very fast, much faster than we can even think. That's the same thing as the double a penny every day thing we did first. It grows a lot quicker than we know. So exponential growth of exponential spread of a virus, exponential growth of a monster, these are things to be very concerned about because it will spread or grow very fast. So not good. Otherwise, I think that's enough for today. I have a feeling I've thrown a lot of math at you today, so I think that's enough. If you have any questions, hang out. Don't forget, this Thursday is the first day for the office hours, and then every Tuesday and Thursday after this, that same link that I showed you will take you to office hours at that time. You don't have to come. You can just come in the middle and stay for 3 minutes. Do you understand? Just like a normal office. Okay. So is anybody with questions? Get back to, that's what I don't understand. Dadgum, there it is. There we go. Everybody all right out there? If you don't have any questions, you don't have to stay. If you have a question, ask away.
Can you hear me, Jeff?
Yes.
Yeah, I was trying to keep up there, but I got a few things that I'm turning this Linnell. But I'm catching it little by little. That one kind of threw me for a loop.
Yeah, that one, this is a lot. We did a decent amount today. And
Yeah.
I try to go.
But yeah, I'm gonna just try to go back over it through the recordings and stuff like that.
The book
But
does a good job of building it too, so you can look at what the book's examples do.
okay.
Yeah.
Okay.
So and then
Well, at least I know when your hours are now, so they're gonna be their set time of hours, and so I can catch up that way. Thank you so much for today. All right, have a good one.
you too, man.
I have a question about the homework.
Yes.
It's on like page 55 and 56. On page 55 and 56, the exponential growth. I know you wanted us to show the work, but to show the work of all
Wait,
of
we're
it.
talking about with number 7, 8.
Well, yeah, I mean, just all of them.
All right. So the first.
To show the work, it's going to get like really, really big because you have the exponents. You have to multiply the same number over.
Oh, no. Okay. All right. We're getting to the point. This is a good question. We're getting to the point where show the work means set up the equation, set up the expression.
Gotcha. All right.
I would never expect you to do this by hand.
Right.
So the work for this is exactly what I wrote. And then
Gotcha.
you throw that in the calculator like we just did.
Okay, wonderful.
The very first assignment and like the very first couple assignments, I needed to see all the work just to be sure where people were. Because I have people that have trouble with 2 minus 7. And then I have people that have no trouble with, 7.83 times 64.721. So I have to know kind of where everybody is. But now we're to a point where the work will be setting things up. And then you throw it in the calculator.
Awesome. Okay.
Yeah,
Thank you.
I understand they're concerned.
I was like, oh man, it's gonna be.
No,
All right.
I got you. All right, man.
Have a good one.
Take care.